Hi, my name is Jiayuan Ding, and today I'm going to introduce to you the topic on radiation in Hanford. This is the table of content. The objective of my presentation is to help you to identify the source of radiation exposures and to further explore the doses from radiation sources. Then we're going to learn about the Hanford nuclear site and its relationship with radiation. And finally, we're going to learn about how to reduce radiation exposure and what to do in a radiation emergency. Here is a pie chart of source of radiation exposure. All of us are exposed to radiation every day, from natural sources such as mineral in the ground and man-made sources such as medical X-ray. According to the National Council on Radiation Protection and Measurements, the average annual radiation dose per person in the US is 620 milligram. Most of our average annual dose comes from natural background radiation source. Among these, 37% of background radiation is radon and xenon, the radioactive gases which are created when other naturally occurring elements undergo radioactive decay. And there are radiation from space, which are also known as cosmic radiation, including the solar events and flying on airplanes. And there are also naturally occurring radioactive minerals such as internal that are in your body and terrestrial that are in the ground. Now we're going to look at a table that says the doses from radiation sources. From this table, it indicates that we're exposed to radiation from various common radiation sources. The highest doses come from medical checkups such as whole body CT, which is high as 1,000 milligrams. And we're exposed to relatively high level of radiation in daily life at our house. It's as high as 228 milligrams. Radiation doses also very different from different locations. Living in Denver has higher average cosmic radiation doses than living at sea level because Denver has a higher elevation. The plot on the right shows other sources of ionizing radiation which Americans are commonly exposed to. We can see that annual nuclear worker doses limit is high as 5,000, and none of the daily radiation or medical checkers can even get close to this limit, which indicates that radiation that we experience every day is not having a significant harmful effect on our health. Now we're going to look at the US radiation graphic map. The solar events are a part of cosmic radiation, and we learned that from the previous table that doses of cosmic radiation varies in different locations. And red night has 140 radiation air monitors in 50 states and runs 24 hours a day, 7 days a week, collecting near real-time measurements of gamma radiation. Over time, red night sample testing and monitoring results reveal the normal background level of environmental radiation. According to the map of NREL, solar radiation can vary from geographic locations. In the map of solar radiation, it clearly indicates that states in the southwest direction has more solar radiation exposures, which confirmed our theory from the previous table. Now we move on to Hanford. There's a nuclear site located in eastern Washington state, Hanford, and encompasses more than 500 square miles of land. For nearly 30 years, the U.S. Department of Defense and the Department of Energy produced tons of plutonium for use in the atomic weapon program. Activities in Hanford produce significant quantity of waste containing hazardous chemicals and radioactive materials. Some of these pollutions leak into land and water, including into the Columbia River. The graph below shows a plot of excess radiation to which people living in Hanford were exposed each year. Due to weapons development as a plan, the red line shows the exposure of residents of Richland in Washington. The maximum measured exposure was about 140 milligrams during year of 1960. In a short term, the sudden dose of a large amount of radiation can cause a wide range of health effects, from changes in blood chemistry to death. Short-term exposure to tens of grams of radiation will likely to cause noticeable symptoms or illness. A dose of about 500 grams is estimated to have a 50% possibility of causing death of the victim within 30 days. Exposure to a radioactive emission has a cumulative effect on the body during a person's lifetime, which is another reason why it's important to avoid any unnecessary exposure to radiation. And now we're gonna talk about the ways to reduce radiation exposure. So we need to limit it or minimize the exposure time to reduce the dose from radiation source. And the dose of radiation decrease dramatically as we increase the distance from the source. And by inserting proper shield between you and radiation source will greatly reduce or eliminate the dose that you receive. So in a radiation emergency, you may ask to get inside of a building and take shelter for a period of time. Staying inside will reduce your exposure to radiation, and emergency officials are trained to respond to a disaster and situation and will provide specific actions to help to keep. Summary: we are exposed to radiation every day, and we can only limit the exposure. And radiation exposure vary in different locations. Extended exposure to radiation is detrimental to human health. We should follow the appropriate procedures to limit the exposure in radiation emergency. And here's the reference, and this is of my presentation. Thank you.